Okay, so question 6, June 2016, pretty standard A and B, less so part C, which caused the most problems, but we'll do the whole thing anyway. We've got a normal distribution with mean 240 and standard deviation 40. So that means it's got variance of 40 squared. Okay, now we're asked for the proportion that take more than 300 minutes. So the probability that x is greater than 300 is equal to the probability, and we do our standardizing thing here, which I'm sure you've all seen. So that's equal to the probability that z is greater than 300 take 240 over 40, because that's the standard deviation, not 40 squared. Okay, so that equals to the probability that z is greater than 1.5. So it's pretty straightforward. I always like to draw a diagram with these. Probably don't have to here, but just a good habit to get into. We're asked for the probability. We're being asked for this area here. So we need to look for the numbers in the tables, but basically that's equal to 1 minus probability that z is less than 1.5, because the number in our tables will give us this area. So let's look that number up in the tables. Here, there it is, 0.9332. So 1 minus 0.9332, which is equal to 0.0688. Okay, so that's part A. Part B says Nathaniel is preparing to run a marathon. He aims to finish in the top 20% of the male runners. Using the above model, estimate the longest time that Nathaniel can take to run the marathon and achieve his aim. Now, you've got to kind of understand the reverse logic here. If he's going to be in the top 20% in terms of finishing time, that means that we need this number here to be 20%, because the lower the number, the faster they are. So the top 20%, it's kind of reversed, will be the 20% actually smallest in terms of time. So we're looking for the appropriate z number we're going to be looking at here. By symmetry, I might actually just find what this number is and just know that this is going to be the negative of that. So if we've got 20% here and 20% here, we'll be able to find the appropriate z number and work backwards. So let's just go back to the tables and look for that. Well, I suppose you might look for where 0.8 is on these tables here, and you can see that the z number we want is somewhere between 0.84 and 0.85. But there's more accurate, and this is really what we need to do to get it accurate, because we've got a number for 20% there of 0.8146. Okay, so that's the top 20% in terms of times is 0.8416. So I can put that back into my graph. So this number here, which in fact this would be the slowest people, because they're taking the longest time, the most time, would be 0.8416. So the number we're after, the z number, is minus 0.8416. So let's write this up a little bit formally. Let's call the time n that Nathaniel takes. So we can say the probability that x is the time taken is less than n is what we're looking for, because it's got to be at a certain time or quicker, is equal to, we need that to be equal to 20%. Okay, well we've looked at we've got our appropriate z number here, so that's the same as the probability that z take away the mean, z is less than n take away the mean, which is 240, divided by the standard deviation is 40 equals to 0.2. And as I say, I found this appropriate Z number here. So we can now say that n minus 240 over 40 is equal to minus 0.8416. So I can say that, just rearranging that, n is equal to 240, take away 40 times 0.8416, and to three significant figures, that comes to 206 minutes. Right, okay, so that's part B. A little bit more difficult, but still okay. I suppose the main sort of thing you're looking for is the right side of the distribution. It could be so tempting to go for the higher, thinking that was quicker, but of course it's not. Right, now this is a bit unusual, and it's nothing to do with looking at tables. It's another, they seem to like conditional probability questions recently, and this seems to be the case in S2 as well. They're throwing in conditional probability questions all over the place. There's already one or two elsewhere in this paper, and they really do like it. And this is a completely different type of question. So they're getting imaginative here. So they're very pleased with themselves. So anyway, what we've been this is the times for women is normal distributed with mean mu. Doesn't tell us the standard deviation or anything, but it does give us that the probability that W is greater than mu plus 30 is equal to 0.82. So I'm going to draw my bell curve. So what it's told us is the probability that mu, I've got mu here of course, and I've got mu plus 30 here. And it's telling us that this area is 0.82. It might be more helpful to highlight what this area is here, and that's 0.18, 1 minus 0.82. Okay, so by symmetry, we can say that this number here, which is mu minus 30 here, that this area here would also be 0.18. So let's just look at what we've been asked for here. We're saying given that W is less than U, so we're in this kind of area where we know we're halfway along here. And we know that this area is 0.5. I might put that in a different colour actually. So this area here, this whole area, is 0.5. Because it's halfway along by symmetry. So I'm going to use a similar approach, not make too much of a big deal of this, just use a kind of more, well, sometimes called a restricted sample space. We know that this is going to happen now, that we're in the lower end, so that's the 0.5. And of those, we want to find a probability that they're actually less than 30, so that's 0.18. So, writing out the question, probability that W is less than mu minus 30, given that W is less than mu, equals to 0.18. That's that number here, which is what we've been asked for the probability of, given that we know that we're in this side. So that's 0.5. So that's 18 over 50, or 0.36. Okay, again, as with the last one, if you think this is wrong, I'm really rushing these out now, let me know. I have looked at the marks things, I don't think it is, but if you think that it's wrong or you want some further clarification, please do fire away. I'm going to try and get maybe another question out. I don't think I'm going to have time to finish all the questions from this paper.